A hybrid meeting on the Pike Solar Array was held on May 15, 6:30 p.m. at the Colorado Springs Utilities Facility on Mesa Road in Colorado Springs. The event was hosted by the IEEE Pikes Peak Section in conjunction with its IEEE Power Engineering Society chapter, as well as being co-hosted by the Foothills and Baltimore Peace chapters and the Denver Life member Affinity group. Our speaker was professional engineer Steve Schaarschmidt, a principal transmission operations and downtown network engineer with Colorado Springs Utility, or CSU. Attended by 21 people from the Pikes Peak section, along with 8 people joining the meeting online. A pizza dinner was served, and there was some networking time following the presentation. Our host for the event was Birgit Landon of the CSU Customer Relations Department. During the meeting and after the presentation, special attention was given to a life member and vice chair of the IEEE Pikes Peak Section, Jean Freeman. Jean was the 2023 recipient of the Jim Leonard Award for IEEE Outstanding Member shown here. This prestigious award was presented by the chair of the Pikes Peak Section, David Bondurant. The Pike Solar Array, a photovoltaic solar installation situated on a 35-acre plot of land near the Pikes. A fountain, Colorado boasts a capacity of 6.4 megawatts and over 20,000 solar panels generating clean energy for the local grid. The Pikes Solar Array, located south of Colorado Springs and east of the Nixon Power Plant, houses major CSU coal and natural gas power facilities. Moving east from I-25, you can see the Palmer Solar Array, 60 MW, completed in 2020 and went online this year. The gross power of the Pike Solar Array facility is 223. 6 megawatts, occupying 1,300 acres, consisting of about 415,000 solar panels with 545 watts per panel. A peak power output of 175 megawatts can be reached after internal losses. To track the sun during the day, the solar panels rotate from east to west. During operation, grid-following inverters must synchronize the array output with the system frequency and phase. The solar array generates 600-volt output that is up-converted to 34.5 kilovolt and sent to a substation where it is up-converted to 120 kilovolts. According to Steve Schaarschmidt, the array operates at about 20% average power efficiency when effects of darkness and weather are factored in. Colorado Springs Utility currently is producing more than 20% renewable energy to meet state mandate. This power comes from solar, wind, and hydro, 35 MW sources. Overall CSU peak demand was stated as about 900 MW. Steve explained that this represented only about 0.5% of the power demand in the western U.S. grid, which CSU is a part. Its demand is 180 GW. Pike Solar Array site tour was held the following day on 16 May 2024. On February 13, 2024, Juvie brought the largest photovoltaic project in their history online, providing an output of 223.6 megawatts. Juvie has built a solar park for the energy company Deriva, formerly Duke Energy. The Pike Solar Farm will supply energy to the regional American energy supplier Colorado Springs Utilities CSU under a 17-year power purchase agreement. At the start of the tour, a group of 8 people gathered at the operations and maintenance office and were given hard hats and safety glasses to keep the grass down, as well as getting rid of weeds. About 1,300 sheep graze under the solar panels.
Now the funny thing is the solar plants being done, but we don't normally have them tilting. They're usually fixed, and grass doesn't grow underneath, so it only grows where the light lands. Yeah, and those are monofresh as opposed to these. So I think that will affect that. This is great.
I think that's one of the power stations. One of the little collection stations for MVA transformers. I think that's where we're going to go. That's why you brought us to this area.
144 solar cells with about 30 solar panels mounted on a rotating pole. The panels are connected in series to create a 600-volt output. Mounted between several rows of panel is a single motor that rotates the panels from directly east to directly west during the day. To track the sun, position sensors determine the correct angle to maximize solar output. A total of 690 of these motors are installed in the Pike Solar Array. The solar panels are rated to withstand greater than 120 miles per hour wind speed, but to prevent damage, the panels must be rotated to specific angles during the high wind events. In addition, the panels are susceptible to hail damage. For example, during installation, approximately 5,000 panels had been damages out of the over 415,000 panels. As a result of this experience, panels are rotated to a correct angle during operation to minimize hail damage when a hailstorm is predicted. Here you can see the top black wires below the motor for motor control, while the bottom red and black cables are 600-volt outputs connected to the circuit breaker box from the rows. The 600-volt cables terminate in circuit breaker box to allow rows to be isolated for installation and repair. The box outputs to the grid following inverters. Shown here is the large grid following inverter. It receives the 600-volt inputs from multiple rows of the array, convert from DC to AC voltage, and upconverts this voltage to 34.5 kilovolts, which is sent to a power substation nearby via buried high voltage cables. There is a total of 96 of these inverters in the overall Pike Solar Array. After seeing the basic functional parts of the solar array, the group headed for the nearby substation handling this field of panels. Several fields of panels make up the overall Pike Solar Array, the buried 34. 5 kilovolt lines from the field of solar panels come out of the ground and are connected to large circuit breakers, the gray boxes. The outputs from these circuit breakers are connected to a transformer which upconverts 5 kilovolts to 120 kilovolts, which connects the field to a nearby Colorado Springs utility substation. This substation all the solar field outputs and send the power to Colorado Springs via 2 major transmission lines. The site tour group is shown in front of a row of solar panels. Our JUI hosts are shown with orange vests. Our tour host from CSU, Brittany Harrison, is shown in purple shirt. Our speaker from KSU, Steve Schaarschmidt, is shown fourth from the left. The Pikes Peak Section appreciates the support of CSU and JUI to make this 2-day event possible.